So we're doing B. Hey, hello. 8B says the log of the square root of x7y cubed. So we're doing the log of the square root of x to the 7 and y to the 3rd, right? They're both under the square root sign, right? So if you like, you could write them as individual square root. That's one way of doing it. We could do it that way. So I'm going to show you two different, because I know some people use a different method. Or, for step 1, some people will just have written the log of x to the 7, y to the cube to the 1/2. Because the square root sign we said yesterday was a half power, right? Correct? If you started this way, your next step will be, this is a multiplication. If it is a multiplication, we add, right? We expanded it. So this is the log of the root of x to the 7 plus the log of the root of y cubed. Okay, there's an or this way. We're going to finish the or on the other end in the log. Now I get to write this as the log of x to the 7 to the 1/2, because that's the square root. All right, the square root is going away now. Plus the log of y cubed also to the 1/2, because they're both, we're sharing the square root. Right? So there was a property, well, first thing, properties of exponents, power to a power. What do? Multiply. So this is the log of x to the 7/2. I haven't seen you in a minute. Plus the log of, are you okay?
Yeah, I was just showing how it does.
I know. Only thing that brings you to my room, nice classes. We're on track to graduate?
Yes.
You sure?
Yeah.
All right. We good? So now there is a property that says when I have an exponent, what do I do with it? I can move it as a multiplier, right? So this becomes 7/2 the log of x plus 3/2 the log of y. 7/2 plus 3/2.
This is the,
Mm-hmm.
so I got that answer,
Mm-hmm.
but I thought that was the same answer.
Oh, there's 7.2? No, it's just 7 divided by. So nice.
I got that
You
answer.
got that. That's good. That's nice. Let's step up. Let's just step up.
Oh.
And, or if you did it this way, those people who did it this way, I could just take this and bring it here. 1/2 the log of x 7 y cubed. They're all sharing this 1/2. 1/2 the log of x to the 7 plus the log of y cubed. 1/2 times 7 the log of x plus 3 the log of y. Right? This is also equivalent to that, because when I distribute, I get, right? It becomes a 7/2 the log of x plus a 3/2 the log of y. Either way, this is the same thing. Questions? So tomorrow we have an assessment. We talked about that yesterday. The assessment is going to be over the properties of logs. Okay? Just the properties. So those of you who forgot what those look like, on page 78, you have that table, that page that's up on the screen. Everybody, in your holy books, go to page 78. So yesterday we had this thing on the board, right? Condensed and expanded, condensed, expanded. Right? It's not short, it's just condensed. Fun size. But we do have that if I have log with a multiplication of the argument, I'm gonna put two arrows because we're gonna go back and forth, right? This is not a one-way street. It's not downtown Minneapolis. This is a two-way street. So we said we could write that as the sum of the individual logs. Right? That was one property we looked at. So this is, we're gonna go over this real quickly because we've looked at these a lot. This is the log of the difference, or the difference of the individual logs. Right? And then we had another property that says okay? And then somewhere along the way, a few days ago, we stumbled across another property when we had all those negative answers on the board. And I said, stop and check and see what they have in common. And we came up with this piece. Right? And we had all those negative answers. Because then we ended up talking about if I know what's 2 to the third, then I also know what's 2 to the negative third. Because if 2 cubed is 8, then 2 to the negative 3 power is 1 over 8. Okay? Spend a lot of time talking about those. But these are the properties that you should remember. And this one, really not a property, but we talked about it. It's just knowing something. Some people call it a property, but the log of 10 to the x is just x. We talked about that a lot, right? That's how we got a log of a 100 being 2, because we said there is a base 10 here that we don't quite write. So we're asking what power of 10 give me 10 to the x? Well, x.
Yeah.
Right? Okay. So let's do some work. Because I did say today was going to be review day. So this is the day I do all the talking. And then we just do all the asking. So if you look at this page up that's projected, properties 5, 6, 7, 8 technically are the ones we're dealing with. 5, 6, 7, and 8. Okay? I have a pass here for somebody. Yeah, Max. Okay, so let's look at problem set 1. So problem set 1. You're given values, just like we did the last time we had tables, right? And you have to now use the properties of log, and with the restriction on the values you're given, you can only use those values to find whatever we're asking you for now. So you're given the value for the log of 2, the log of 3, the log of 5, and the log of 7. So 2, 3, 5, 7. Okay? We have to use those as factors, as prime factors, the prime factor, the numbers they gave us, and then use the properties of log. So for example, Problem A says to find the log of 6. How do I find the log of 6 if I'm given the log of 2, the log of 3, the log of 4, no, the log of 5, and the log of 7?
Log of 2 times log of 3.
The log of 2 times 3, right? Because 2 times 3 is 6. Pay attention here, folks. So A, the log of 6, and he says 6 is 2 times 3. Right? Doesn't change anything because 2 times 3 is 6, and 6 is what we're given. Now I have a multiplication in there. On this way, which property do I apply to expand it out? First property. So this is the log of 2 plus the log of 3. Questions? What is the value for the log of 2? Are we given that? Yeah, what is it? 0.3010 plus, what's the log of 3?
771.
That's work on it. Right? So now we just need to add those two pieces up? All right, somebody add it from here and tell me what will be your final answer. 0.7781?
Yeah.
Get off the phone. And kick you, man. Make me contact with you. Okay. Questions? So the next one says the log of 15. How do I find the log of 15 given what I have? 5 and 3. Why? Because 3 times 5 is 15.
Oh, wait. I got a question. Why'd you go from multiplication to adding?
And it helps if you're not coming to school every other day. You know, take a vacation after every day you show up. Yeah. So the log of 15. Folks said 15 is 3 times 5.
Oh, I thought.
I thought I was the only one that heard that.
Because again, every time we have the multiplication of the argument is the sum of the individual logs. So do we know the value of the log of 3? Yeah, we still got it on the board here, right? Do we know the value of the log of 5? Yeah, so you add those two values together, that's your answer. You got an answer, Emmanuel? What is it? 1.1761. Okay. Thank you. Okay. So here's a little bit of a critical question. I know the value of the log of 2. I know the value of the log of 3. I'm giving the value of the log of 5 and the log of 7. Those prime numbers. Now they're asking me to find the log of 12. I need some suggestions. How do we find the log of 12? She said 2 squared. Why 2 squared? Because it's equals to 4. She's doing 4 times 3. It's 12. But we don't know what 4 is, right? But we know the value of 2. So 2 times 2 is 4, which is 2 squared. So 2 squared times 3, right? Another thing we could do, though, is go back here to A. Didn't we just find the log of 6? in problem A as problem A. So 6 times 2 is 12, right? So I just take the answer for A and add a log of 2 to it. That's it.
Oh, yeah.
Just do the answer for A plus the value of the log of 2. Grab the mic. You done. We see that? Questions? Ask now, because tomorrow, you know, your hand goes up, my face goes. Got a question? No? The next one. The log of 10 to the 7th. Log base 10 of 10 to the 7th. What power of 10 gives me 10 to the 7th? 7. The log of 10 to the x is x. We've done that a lot, right? Everybody seen that? Anybody stuck on that? Okay. I'm rushing because I wanted to get to E, F, and G. So let's do E.
Look at that.
You just don't like little bitty numbers?
I don't like
You like big numbers like 1 and 2 and 3, hit little bitty numbers like 1/5.
It's the fraction.
You're just afraid of babies. You know you can't buy anything in this country without fractions, right?
They look huge.
You go buy some shirt somewhere, it's like $13.99, $13.98. It's never quite $14 exactly. It's never quite $15 exactly. They always have a fraction in there, right? Because the 99 cents is 99 over 100. Right, or 98 cents, right? Like, can you just make it the whole dollar? Okay, so let's do E. E wants us to find the log of 1/5. Ah, good. But can somebody see it another way? She says we could do this. This is a division, because fractions are division technically. It's 1 divided by 5. Right? So she's saying that we could apply this property as the log of 1 minus the log of 5. What is the log of 1? Why? Oh, you're right. I just want you to justify your answer. So let me ask the question the other way. When I'm asking what is the log of 1, I'm asking what power do I raise 10 to get 1? You already give me the answer and you say you can't?
You can't raise 10 to 1.
So, properties of exponents. We had this thing, you see how the blue sheet, properties of exponents? Look at the zero property. It's right in front of you. Look at the zero property. It says anything to the 0 power is 1, and if that thing is not 0, right? 10 is not 0. So 10 to the 0 power is 1, therefore the log base 10 of 1 is 0, which is why you were right. But you gotta be able to justify your answer.
I didn't know this. That's why I said it.
Yeah, that's the reason. Because 10 to the 0 is 1. So then we have a 0 minus the log of 5, right? So if I follow her method, this will be the log of 1 minus the log of 5. This is 0 minus the value of the log of 5. Can somebody give that to me, please? 0? Okay. Right? So what's 0 minus anything? It's the negative of that thing, right? You had nothing and you want to spend 69 cents. Well, you gotta borrow money. Yeah, thank you. Appreciate that. That is one way to find it. Another way that I was hoping people were gonna see is they're asking us for the log of 1 over something. Which property here tells me I can do the log of 1 over something? Yeah. So this is equals to negative the log of 5. Isn't this the negative the log of 5? That's why that thing works out. Because we're always going to have the log of 1 minus the log of the denominator, and then the log of 1 is always 0, so we 0 minus that thing. So just the opposite of that thing, the negative value of that thing. You see that? Anybody with a question? Please speak now. Well, then we'd find the value of the numerator. Then we still do the same division piece, right? Of course. No, it's this thing.
How we get that? How we get?
It's right in the book. You know,
Like they're saying, y'all, pay attention.
we good? Okay. F now answers your question. What if the numerator isn't 1? Well, we still deal with it, right? So, can I take this off the board? All right. So F wants us to find the value of the log of 3/7. That's a quotient, right?
Yeah.
So we write there as the log of 3 minus the log of 7. Do we have a value for the log of 3? What is it? 0.4771 minus log of 7. 9?
1.
See that? Now we just subtract them, whatever the answer is. I'm going to give you part of the answer. It starts with a negative and a 0 point. What's the rest of it? Can somebody give me the final answer, please? Just a push button, this kid is. Negative what? 868? I was gonna be like, that is not possible. Okay. So, applying properties. So, G, problem G is asking for the log of the 4th root of 2.
That's how you say that?
Yeah, 4th root.
So 20 is like the 21st root.
So 68 plus 1 is like the 68 plus 1th root. But you know, when we add it up, it will not be the first, right? Because 8 plus 1 is not the first, right? It's a 1. Make your stuff up, man. That's what we do. Okay. We learned yesterday, though, how do we write that radical as an exponent? The 2 has an exponent of 1, okay? So, all right, it's 2 to the 1/4. Now, what property do we apply to that? What property? The third one, right? So this becomes 1/4 times whatever the log of 2 is. What's the log of 2? 0.3010. Okay. So this is 1/4 times 0.3010. Your cousins before you went, Mr. Goya, while we multiplying fractions and decimals, and to them I went, okay, we will still write it as, how do I write 1/4 as a decimal? Yeah, because we're just asking for what's a quarter of a dollar, it's a quarter. So 0.25 times 0.3010, whatever that answer gives you. Product is what we got. You just basically pick up that one. Work.
Are you asking?
Oh, whatever it is, that's what you write there. So do your multiplication, people. Use your external brains and your fingers. Plug this thing times that thing. What's a quarter? 0.25.
You didn't ask.
Yeah, I didn't ask. Again, I'm not sure I am. Well, don't go very to it. Just go condensed. Very condensed. I heard that, just so you know.
That's what you said.
Let's do number 2. Number 2. We're still doing what we had in number 1. In number 1, we're given exact numerical values. We said the log of 2 is 0.301. Therefore, wherever we see log of 2, we just substitute 0.301, right? That was a statement based on a specific log and numbers. Now, we want to make a generalized statement. Right? Now we're giving variables. Right? Mr. G is me, Mr. G is short, next thing you go, short people mean. Right? Generalized statement. Stereotype. Teenagers that shoplift at Walmart, now every teenager that goes into Walmart, people think you're going to shoplift. So let's do that now. Let's stereotype in math. Except in math, it makes sense. It's good. The stupid stuff they do is not right. Because they don't know old people that don't be shoplifting too. But they don't be checking.
Why is
Right. Like, oh, it's going to be the kids. No. That's the distraction. Kids, run around, distract them. All right. So this is this is saying everywhere we see the log of x, we should represent that as r. Everywhere we see the log of y, we should represent that as s. And everywhere we have the log of z, we should represent that as t. Now we need to write these values only in terms of r, s, and t. Just like we wrote the other values only in terms of 2, 3, 5, and 7. Remember that? So let's do the first one. First one says the log of x over y. What property do I apply here to extend? The second one, which says the log of whatever the value of x is minus the log of whatever y. We good? Well, the instruction says everywhere I see this whole thing, log x, what does that represent? R. And then everywhere I see log y, what does that represent? S. So now I got R. That's the answer. Now this thing is in terms of R and an S. That's it. What? Questions? It was kind of easy, right? It's math. It's supposed to be easy. Y'all just make it difficult. We're good? So then I need you all to try B on your own. Take 35 seconds. Do problem B. Problem B is asking you for the log of x times y. Write that in terms of R, S, and T. Oh, C rather, Y, C. Sorry. The log of Y and Z. 20 seconds. Okay, who have an answer for me?
S plus T.
Hmm?
S plus T.
S plus
S plus T.
E.
Where you get E from?
E.
How you get Z?
X plus T.
Wait, they keep helping you with that. You know what? I'm not taking your answer. I said Z. I'm stuck on Z. Yeah. So we're adding, right? It's a multiplication, right? So we know the value of log of y is S, and the log of Z is T, so S plus T. Everybody see that? Questions? S plus T. S plus T. Yeah. This is what it did. Right? So if you look at the top of that page, you say, everywhere I see this thing, what should I represent it by? Look at the top. What should I represent this by? Okay. I did. I understood. That's why I went back to it. So let's do C. Let's do C. Anybody, real quick, mental math. Who can win there real quick? The log of x to the r. So say what again? R times r. Somebody, r squared. Somebody says what again? R squared. We all agree it's r squared. Why are we doing r times r? Because of this property. Right? So the log of x to the r, right? Watch it now. You on this wrong. Is r times the log of x. We get it stuck on that phone today. We're good? So we say wherever we see this thing, what do we put? Oh, we already have one here, right? So this is this r times this r. Properties of exponents. When we multiply, same basis, we add the exponents, right? So 1 plus 1. That's how they got it. Well, if you stop texting, yeah, so we have this, see this property that says if I have an exponent, I can bring it down, bring the power down. So we've got this power down. But then we know the log of x is what? R. We already have one R here. So R times R. X times X is X squared from properties of exponents, right? So R times R is R squared. Okay. Good. So, see, D, we did D yesterday. How do I write a cube root as a power? 1 over 3. Because we said the fourth root was 1/4. So the cube root is 1 over 3, because the square root was 1 over 2. We did that yesterday. So then, I would write D as starting out as the log of z to the third. Because that's the cube root. Now we're back to applying the same property we just did before that, right? So this is what? 1/3 times the log of z. But the log of z is what? So 1/13. Questions? So for E, they all live under their fourth root.
Yeah.
So they all share the fourth root, just like the other example we did earlier. Okay? Same thing. F, we did similar example yesterday. Right? We did this example yesterday. What's the operation going on in here? It's a multiplication. So that means, so every time I have a bunch of stuff together without any symbol between them, it's a multiplication. So just like Alright? My name is just a multiplication. G times O times Y times A times H. Is it? The log of G plus the log of O plus the log. Right? OIMs? Exactly. So then, if I am given, we're given the log of 3 times what? X. Oh yeah, I already told you how to do that. Yep. So X, Y, Z. What's the power on the 2 and 3? So we agree that this is multiplication, right? So the log of X plus the log of Y squared plus the log of Z cubed. I know the log of Y, but I don't know the log of Y squared. So I have to use the other property that says I can use my exponents as multipliers. So this gives me the log of X, which we know, 2 times whatever the log of Y gives me, and 3 times whatever the log of Z gives me. So X plus 2 times Y plus 3 times Z. So what's the value of the log of X? R plus the log of Y plus the log of Z. So R plus 2S plus 3T. What's R plus 2S plus 3T equals to? That, right? Because they're not like terms. You can't combine them. Right? A banana plus 2 apples plus 3 plantains. If there's a banana, 2 apples and 3 plantains. Okay? Yeah, we're not making smoothie. Okay? Okay. I give you banana and apples, don't make pineapples or bananas. We're good? Number 2 should be where you go to practice to get ready for tomorrow.